Good morning, teachers and friends. We are going to discuss about halogens today. Number 1, the color of halogens going down the group. The color of the halogens generally get darker down the group. Fluorine being yellow and iodine being purple, it gets darker down the group. The melting and boiling point of halogens going down the group. The van der Waals forces increase down the group, so the melting point and boiling point increase. The vitality of halogens going down the group. Vitality decreases down the group as the boiling point increases down the group due to the van der Waals forces.
The reactivity of halogens going down the group. The reactivity of halogens decreases down the group as the electrons in the outer shell move further away from the nucleus and there are weaker forces of attraction. Therefore, it is harder to gain electrons. The electronegativity of halogens going down the group. The electronegativity of halogens decreases down the group as the radius of each atom increases due to the more shells. This means there is less attraction between the positive nucleus and the outer electrons.
The displacement reaction of bromine with sodium iodide with the help of cyclopropane. Bromine will displace iodine in the reaction, forming sodium bromine. This is because bromine is more reactive compared to iodine. After that, iodine will react with cyclohexane, which will turn cyclohexane purple. This is how we will know whether iodine is being produced or not. The trend of reaction of hydrogen and halogens going down the group. The rate of reaction between halogen and hydrogen will become slower as we go down the group. For example, the reaction of fluorine and hydrogen will be explosive. But if we look at the reaction of bromine and hydrogen, the reaction will occur slowly.
Now, considering the thermostability of the hydrogen halides, it decreases down the group. This is because as you go down the group, the halogen ions increase in size, making the bond length larger, thus making the thermostability lower, as it is easy to separate the bonds. Now, the way you can test these halide ions in the laboratory is that you need to use nitric acid and silver nitrate. If you add them to the solution, this will result the halogen to form an ionic bond with the silver and form a precipitate. The color that precipitates are as such. Chlorine will become white, bromine will become green, and iodine will become yellow. However, the color of these precipitates are really hard to differentiate. So we can use dilute and concentrated ammonia to see which one is which. For example, silver chloride can dissolve in dilute and concentrated ammonia. Silver bromide cannot dissolve in dilute and can dissolve in concentrated, and silver iodide cannot dissolve in both.
Hydrogen bromide and hydrogen iodide cannot be prepared with concentrated sulfuric acid, which is a powerful oxidizing agent as they are easily decomposed. This is because hydrogen bromide and hydrogen iodide has a long bond length due to the size of the ion, and so they have a low bond energy that can easily be broken. As you can see in the picture, as the atom is large, there's a long distance between the two nucleus, and that's why the bond length is larger. And you can see the reaction for the sodium salts with bromine and iodide. As for the disproportionation reaction with chlorine and alkalis, you can see the reaction with sodium hydroxide in two conditions: when it is cold at 15 degrees Celsius and hot at 70 degrees Celsius.